Hello. Today I'm going to talk about a series solution to a non-homogeneous linear ODE. And its first order makes it a little bit simpler, but this is set 15, the last problem. Okay, assume that y is the solution to the initial value problem, IVP, y prime plus 2y equals this mess. The initial condition y of 0 is 1. So I talked about this kind of mess yesterday. One thing I just want to point out that you could put optionally, it's equal to this expression if x is not 0, and that expression if x is equal to 0. So the little blue here is not in your web work statement, but it means the same thing. It has an initial condition y of 0 equals 1. Okay? All right. So if that solution y is written as a power series, okay, then the first few terms of that power series are these. They've written it out. So what you have to do is fill into these blanks, fill in C0 here, C1, C2, C3, and C4. You just got to figure out those first 5 coefficients and putting them in. You don't have to find a formula involving n for Cn. I'm not sure if there is one. A nice one. Okay, so to make myself a little bit more room, let's just at the top put in what our goal is, right? We want to find y is blank plus blank times x plus blank times x squared plus blank times x cubed plus blank times x4 plus dot dot dot. Okay, I'm going to fill in those blanks. And the other thing is I'm going to not use the summation notation. I'm just going to, instead of this, write out what it says. Y equals C0 plus C1x plus C2x squared plus C3x cubed plus C4x to the fourth plus dot dot dot. So we just don't need this anymore. So, I mean, I could sort of say here this, like the international symbol for no sigma notation, right? Okay, I'm not going to use the sigma notation. You could, if you want, just going to write it all out. Okay, so actually we can get rid of everything here below that. All right. So if I have that, then it's easy to differentiate. Y prime is, I might write a C1 right here underneath that C1x, but instead I'm going to move it over so the constant terms are on top of each other, and this is plus 2C2x. So the x terms are on top of each other, plus C3C3x squared, plus 4C4x cubed, plus dot dot dot. The dot 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 start earlier in the y prime, but that's okay. All right, so I want to set the left-hand side, I'll use LHS for the left-hand side, equal to the right-hand side. Okay? All right, but before I do that, actually, I want to fill in one of the answers. There's something without doing any work. One of those 5 boxes I can fill in right away. Can you see what that is? Right here. This is a 1. That's a 1. This says that C0 is 1. right? The constant term in the solution is 1, because y is 0 is C0 plus 0 plus 0 plus 0 plus 0, that's forever. Okay, so 20% already. Okay, so now let's get back to this thing with the left-hand side and the right-hand side. What is the left-hand side of this ODE? Well, I'm going to write it instead just as 2y plus y prime. I'm going to write the 2y first, just so when I add this, twice that plus that, it'll be a little bit nicer to have the C0s first. So this is going to be 2C0 plus C1, that's the constant term, plus 2C1 plus 2C2 times x. They're the two terms that involve x, plus 2C2 plus 2C3 times x squared, right? Plus 2C3 plus 4C4 all times x cubed plus dot dot dot. Right? Okay. So the constant term, in fact, I can put that in parentheses as well, just to isolate it. Got the constant term, the coefficient of x squared, coefficient of x cubed, and I don't really know the coefficient of x fourth because I would need C5 to get it over here. So I'm fine to stop there. So now let's do what the right-hand side is. The right-hand side is, well, as I talked last time, it has this split definition, and it might worry you a little bit, but the point is that this formula is fine, and this point here will just come in automatically. So let's the right-hand side, we can write it as 4 over x times arc tangent of x. Okay, and and you'll probably have an arc sine, but that's okay. We're going to fill in the known series for arctangent. The known series for arctangent, which you can look up if you don't know, is going to be x minus x cubed over 3 plus x fifth over 5 minus dot dot dot. It's alternating. And it's a lot like the series for sine, except it doesn't have 3 factorial and 5 factorial, so it just has 3 and 5. Okay? And again, this expression is not going to work when x is 0 because you're dividing by 0. But if I manipulate this, I can take each one of these terms, divide by x, so I get 4 times 1 minus x squared over 3 plus x to the 4th over 5. Oops, plus dot dot dot, or I guess I could say minus dot dot dot. All right, that's the series. So when I multiply through by 4, the right-hand side is actually 4 minus 4/3 x squared plus 4/5 x to the 4th minus dot dot dot. Okay, and I used that, or I got this expression using the formula that's good when x is not 0. But if I can plug in x equals 0 into the series and get out 4, which I should. Okay, so we talked about that in yesterday's video. All right. So now all I have to do is set the left-hand side, which is a function of x, to equal the right-hand side, which is also a function of x. And to make those functions of x the same, got to make each coefficient the same. So actually, I don't need the equations anymore. All I need is these left-hand side and the right-hand side. So I'm going to get 5 equations for the 5 unknowns C0, C1, C2, C3, and C4. And I'll remind you where they are here. This is C0, here's C1, here's C2, here's C3, and here's C4. Okay, the first equation comes from y of 0 equals 0. Sorry, y of 0 is 1. Therefore, the first equation is C0 is 1. And then I get x to the 0 coefficients. Terms are the same. Therefore, I get this equals 4. I get 2C0 plus C1 is equal to 4. Okay? Okay, and then I get the x1 terms same. Therefore, I get 2C1 plus 2C2 is equal to, wait a minute. I don't see an x term here. What does that mean? That means this is 0, right? Because this is really plus 0 times x plus 0 times x cubed, etc. The terms I don't see means the coefficient is 0. Okay? And then we have the x squared terms equal. Let's just get rid of that. X terms are the same. That means I get 2C2 plus 3C3. That's the coefficient of x squared. That's minus 4/3. Make myself a little bit more room. The x cubed terms have got to be equal on the left and the right. They're the same. So I need that 2C3 plus 4C4, that's got to be 0. Okay, so I'm going to actually box these equations. They're nice. And like we had before, it's a good idea to write them all out and just make sure they follow a nice pattern, right? I have all these 2's, 2C0, 2C1, 2C2, 2C3. And then this has 1 times C1, 2 times C2, 3 times C3, 4 times C4, etc. And then these are the coefficients for the power series of the right-hand side. 4 plus 0 times x minus 4/3 x squared plus 0 times x cubed. I don't even need that 4/5 x to the 4th term. Okay, it doesn't matter. All right, so now I can get rid of everything but our boxed system of 5 equations and the 5 unknowns. First one is pretty easy. I've already filled in C0 as 1, right? So next, now we'll use this one. And this is where they say, just solve them one by one. C1 is going to be 4 minus 2C0. That's 4 minus 2 times 1. Okay, that's 4 minus 2, which is 2. So fill in 2. All right, so now what do we have here? We have 2C1 plus 2C2 is 0. So you can probably see C2 is just minus C1, right? If I bring this over and then divide by 2. So that's got to be negative 2. Okay. So at this point, before I get into something a little bit grosser with fractions and stuff, I suggest that you try the first few terms in WebWork, hit the button to check it and see if you got it right. Because if you made a mistake in C1 or C2, or if you made a mistake in C1, then C2 is going to be wrong. And then C3, they're all going to be wrong, okay, from then on. So in fact, the first time I did it, I went through and did the whole problem. I typed it in and say, oh, The only thing you got right was C0. I said, oh, I had to just, it was not too hard to find my algebraic error, but it would have been nice to find that error earlier. All right. So now I know that's what C2 is, so now I can use this equation to find C3. So I get 3C3 is minus 4/3 minus 2C2. Okay. I could divide by 3 now. Yeah, sure. C3 is minus 4/9 minus 2/3 C2. Okay, and what is C2? C2 is -2. So this is minus 4/9 minus 2/3 times -2. That's minus 4/9 plus 4/3. Okay, so this is going to be minus 4/9 plus multiply top and bottom by 3, 12/9. That's going to be 8/9. Okay. All right. So then you write in 8/9 and check if you got it right. And I'll check that by yeah. I got 8/3. do. Is that right? Oh, that's right. 8/9. I got it right. Cool. All right. So as I say, you probably want to check to make sure before I go on. Okay, so that is 8/9. Now what is, now I look for this for C4. C4, or 4C4 is minus 2C3, or C4 is minus 1/2 C3. Okay, that's minus 1/2 times 8/9, which is minus 4/9. Okay, and that's it.